This is 7.5. I'm just going to go through the My Math Lab questions. Second. All right. This is asking us to rationalize the denominator. What it means is that the denominator of any fraction cannot contain any radicals. So I want this radical gone. This radical is okay. To get rid of the radical 7, because I know 7 times 7 is 49, and the square root of 49, is 7. The square root of 7 times the square root of 7 is 7. Okay, so to get rid of a square root of 7, to turn it into a regular, to get rid of the square root and just have a regular 7, I want to multiply this by itself. Okay, so I'm going to rewrite it. We have the square root of 5 over the square root of 7, and we're going to multiply this by the square root of 7. To maintain equality, I need to multiply the top by the square root of 7. The square root of 5 times the square root of 7 is the square root of 35. Square root of 7 times the square root of 7 is, like we said, 7. Now I want to look at 35 real quick and make sure it is not, you can't divide it by any perfect squares. 35 divided by 25 is not a whole number. 35 divided by 16 is not a whole number. 35 divided by 9 is not a whole number. And 35 divided by 4 is not a whole number. So our final answer is the square root of 35 over 7. Number 2 also asks us to rationalize the denominator. So first I'm going to convert it to the square root of 1 over the square root of 41. Good. The square root of 1 is just 1, so I could even say 1 over the square root of 41. To rationalize the denominator, same thing we did here. We're going to multiply it by the square root of 41. Anything I do to the bottom, I have to do to the exact same thing to the top. So this times the square root of 41. So we have the square root of 41 on top and 41 on the bottom for number 2. Number 3 is the square root of 64 over the square root of x. Same thing, the square root of 64 over the square root of x. We know that 64 is a perfect square. That's because the 64 is 8 times 8. So that becomes 8 over the square root of x. We're going to rationalize that denominator by multiplying both sides by x, or the square root of x, I apologize. So we have 8 times the square root of x over x for number 3. Number 4 is 9 over the square root of 48x. That's all under the radical. 28x, sorry. So I'm going to multiply this by the square root of 28x on top by the square root of 28x. Okay. I do this before I try to simplify the 28 because it just turns out like that, and that's very easy. And then 9 square root 28x. Because they're asking for it in simplest form, and now I do need to think about, can I take 28 and divide it by any of the perfect squares, right? Or more simply, like, can I take 28 and factor out any perfect squares? 28, I know 4 is a perfect square, right? So 28 divided by 4 is 7. I know 4 is a perfect square because 4 is 2 times 2. 7 is a prime, so it's just 7. So the square root of 28 is actually 2 square root 7. You can always check that in your calculator. The square root of 28 and 2 times the square root of 7 should be the exact same number in your calculator. Good. The x obviously is just 1x, so that's going to stay under there with the 7. Okay, and then we have to bring that 9 back. 9 times 2, 18, square root 7x would be my final, over my final answer for the numerator, and then over the denominator of 28x. Oh, we can divide this by something, right? 18 and 28, we can divide them both by 2. 18 divided by 2 is 9. 28 divided by 2 is, I think, 14, right? X square root 7x. So you want to simplify these as much as possible, but it doesn't, these are completely different. So when we simplify these two, it doesn't take this, doesn't change this at all. Look at number 5. And that is 2 over the square root of 5x. take it, multiply it by the square root of 5x. 2 square root 5x over 5x would be my answer here. Okay, cubed roots are a little different because 7 times 7 is not going to equal the cubed root of 7, right? For the cubed root, we need 3 sevens, right? Sorry. The cubed root of 7 times 7 times 7 is 7. So here, the square root of 5x times 5x is 5x because it's a cubed root here. Because, or sorry, square root. Because it's the cubed root here, we need 3 sevens to get rid of the radical. So instead of multiplying it by the cubed root of 7, we need to do the cubed root of 7 times 7, right? Anything I do to the bottom, I have to do to the top. Right? You can also call that the cubed root of 7 squared, or you can call it the cubed root of 49 because 7 times 7 is 49. So you can write any of those right here. They're all the same. So basically we're multiplying 9 times the cubed root of 7 squared, right? And then we're going to do the cubed root of 7 squared times the cubed root of 7. I apologize. It should be that first, right? So that is that. This is our original. I think I made that confusing. All right, so 7 squared is 49. So on top we have 9 times the square root, or sorry, the cubed root of 49. And here we have canceled out, and so we just have 7. Okay, 49. Don't look at the square roots, but look at the cubed roots. Can I divide 49 by any of these? 49 divided by 27. No, right? So that's our final answer. Number 7 is 2 times the square root of 5 over the square root of 3. Again, we're just going to multiply by the square root of 3, top and the bottom. 2 square root of 5 times the square root of 3 over 3. The square root of 5 times the square root of, sorry, the square root of 3 is the square root of 15 over 3. I don't think I can divide 15 by 9 or 4 and get a whole number, so that is my final answer. Number 8 is asking us something different. It's asking us for the conjugate of the square root of 5 plus x. The conjugate, remember, is you take, this is, if this is a plus b, the conjugate of a plus b is going to be a minus b. So in this case, a is the square root of 5 and b is x. So here we have a plus b. Here we need a minus b. So the only change is going to be this minus. A is still the square root of 5. B is still x. So the square root of 5 plus x has a conjugate of the square root of 5 minus x. Nine is asking us the same question. 6 plus c, the conjugate of 6 plus c is 6 minus the square root of c. Sorry, I misspoke. 10 is asking us the same thing. -2 square root of 15 plus 7 square root of z. The conjugate is that same a, -2 square root of 15. Instead of plus, we're going to say minus b, 7 square root z. Question 11 asks us to rationalize the denominator. So this is, we're going to use conjugates. Instead of saying that I want to multiply the top and the bottom by 3 minus the square root of 11, I'm going to multiply it by its conjugate. 3 plus square root 11. 3 plus square root 11. Okay, so now I'm multiplying two binomials. The way I do that is I FOIL. So 3 minus the square root of 11 times 3 plus the square root of 11. First, 3 times 3 is 9. Outside, 3 times 11, square root of 11 is 3 square root 11. Inside, minus 3 square root 11 last. Negative square root of 11 times square root of 11 is negative 11, right? Because negative square root of 11 times square root of 11 is negative square root of 11 times 11, or negative square root of 11 squared, or the negative square root of 144. And all of those, negative square root 11 squared, negative square root 144. Oh, sorry. Yes, I don't know what 11 squared is. 121. Got it. 121. Good. Each of those is just going to give us negative 11. That's how I got that one. Okay. So now I can add 9 minus 11 is negative 2 plus 3 squared 11 minus 3 squared 11. If they have the same square root, I can just subtract them. 3 minus 3 is 0. So my final answer is negative 2. Those two canceled out. 9 minus 11 is negative 2. Look at number 12. I forgot the denominator. I apologize. So the bottom is negative 2. The top is 4. I'll just distribute it now. 4 times 3 is 12, right? 4 times square root of 11 is plus 4 square root 11. Good. Now, since this is a 12, this is a 2, and this is a 4, these are all even numbers, I can divide them all by 2. 12 divided by 2 is 6. 4 divided by 2 is 2. Does not affect the number under the radical. And then the negative 2 divided by 2 is negative 1. Anything divided by 1 is itself, right? But anything divided by negative 1 is negative itself. So the simplest form would be negative 6 minus 2 square root 11. I apologize. 12 is negative 7 divided by the square root of x minus 4. Let's see if I can do this one a little bit better. The conjugate of the square root of x minus 4 is the square root of x plus 4. The conjugate of needs to be applied to both the bottom and the top. So I'm going to multiply negative 7 by that same thing. Negative 7 times the square root of x is negative 7 square root x. Negative 7 times 4 is negative, what's 7 times 4? 28. Over, and now we're going to multiply the square root of x minus 4 times the square root of x plus 4. Square root of x times the square root of x is just x. Square root of x times 4 is 4 square root of x. Negative 4 times the square root of x is minus 4x. Negative 4 times positive 4 is 16. Nope, negative 16. All right. So now we have x, positive 4 square root of x minus 4 square root of x cancel each other out, minus 16 on the bottom. So my final answer is this guy for number 12. 13 is 4 over 1 plus the square root of 6. We're going to multiply it by its reciprocal, 1 minus the square root of 6. 1 minus the square root of 6. Let's start at the top so I don't forget. 4 times 1 is 4. 4 times negative square root of 6 is minus 4 square root 6. 1 plus the square root of 6 times 1 minus the square root of 6 is 1 minus the square root of 6 plus the square root of 6 minus 6. Now you see why it's the reciprocal, right? Because the reciprocal allows us to cancel out the two middle ones always. 1 minus 6 is, and don't think that that's a double minus, because that minus goes with the 6. It's a negative square root of 6 plus a positive square root of 6 to make 0. So 1 minus 6 is negative 5. That's the final answer for 13.